All right, welcome back to this next part. We're going to focus on the Tic Tac Toe game. Previous to watching this, you should have watched all the other videos, and your code should be doing as I have it here. Notice this is my version 0.6. I can either do the ASCII, guess the ASCII character. For example, I can do 0. And it'll say, what is hex 31? Well, hex 31 happens to be the digit 1. So we got that correct. I can also do guess the ANSI keyword by saying I want to play that game, and it says it picked random number 28. So if I count over 28, I'm just going to guess that it's guessing. Say while. Try again. Well, maybe volatile. Try again. Maybe void. All right, that was it. So void was number 28. So we got those running, and of course we can exit. So what we need now is the tic-tac-toe game. So let's go over to our tic-tac-toe.c, and of course when we play the game. Now, tic-tac-toe, a game everyone's played, we know you have X's and O's, and you can you can kind of think of it as an array. In fact, you can think of it as a multi-dimensional array. If we have, we'll do it like this, if we have 3 rows, right, if you picture, we can put X's and O's in each one of these. Right, I could put an X or an O in each one. So for example, maybe I do this, maybe an X and an X and an X. Right, we've got, of course, somebody would be doing the O. Somebody would do a O. Somebody would do an X. Let's say like this. So when you think about this, this is an array here, and this is an array, and this is an array, but we have an array of 3 of those. So what we could say is we have a static, and we could decide if we're going to put characters here. You could argue, since we have X and O's, why don't we put characters, so we could have a static character array of, I'll say, the board, but it's going to be an array of 3 by 3. And notice the syntax of that, 3 by 3. So we have 3 rows of 3 columns, right? 3 columns in each one. So this is a multi-dimensional array. This is the first time we've seen a multi-dimensional array. And so when we play this, the way we'll do it is have the basically the computer will make a move, or you'll make a move, and we'll even have a random choice to see who makes the move first. And then we'll have this board here that's initialized. And you could argue that maybe the first thing we need to be able to do is print out the board, show the current status, and then see whose move it is. In other words, if I'm scoping out what I'm going to do here, I could say, well, this is going to be a do while we're playing. We've kind of done this logic in the others, and we could say integer playing is 1, meaning it's true. And when we come here, what we could say is we draw the board. So draw the board, right? We could do that. And then we need to decide whose turn it is. So somebody needs to make a move, right? So let's see. We'll call it make next move. And we need to just keep doing that until the game, right, there's still more to play. In fact, you could say maybe next move is go tell us whether, right, we should continue on or not. So that kind of scoped it out. Well, we can say this draw board, when we think about it, we'll have a static void draw board, and we'll have to do some stuff there. And then for the make next move, we know that's going to also be a static, meaning it's hidden in here. It's going to return an integer, make next move. And for right now, just as a test, we'll return 0. Right, so we know there'll be no more moves to make because somebody would have won. All right, so far so good. In fact, for drawing the board, I could say this. I could say for integer I equals 0, I less than 2, and I plus plus. So that's going to take us in one direction. And then when you think about the other direction we want to go in is down. And in fact, just to demonstrate this, I believe I'm going to do this. Let's go ahead and initialize this. And how we're going to initialize it, just so you'll see what's going on here, I'm going to initialize it like this. Right? So you see what I'm basically initializing with is the entries. In fact, probably what I should do, this would be 0, 0. Actually, let me do it like this. Since these are characters, I'm going to do it like this. Then we'll say 3 and 4 and 5. And then we'll say 6 and 7 and 8. And what I want to do is show how we print this out. So here's the bigger loop, and then inside of here I'm going to have another loop for integer j equals 0, j less than 2, j plus plus. And of course down in here what we want to do is do a print, and what I'll print is the let's see, I want to print out as a box with a character in it, another box like that. Okay, so I'll do that, and then I'll put the board of I of j. And after it does that, we'll then put a printf, a new line character. By the way, you need to put a semicolon at line 15, put a semicolon at the end of that. Okay, so we're drawing the board. So let's see what happens. We should at least draw the board, right? Let's see what happens. So I'll say, let's do tic-tac-toe. Uh-oh, that wasn't quite what we were thinking. Right, that wasn't quite right. We see we got a 0 and 1, but what happened to the 2? Well, 0, I said I less than 2. It should have been less than 3. Right, so classic example of not having enough. But now let me run it, and I'll do 2. And notice we've got our board. So that's basically our board. And when you think about it, what we could do when it comes time for you to enter your move, you could select that number to say where you want to move. Right, so when you come there, we could say select, we'll draw the board just like this, and then we'll say you decide where you want to move. So what I'll do, if this is the board, I'll say the board static. In other words, static meaning it never changes. But we'll also have a board, so static, character, a board, dynamic. This will be the game, right? How we play the game. But I'll initialize everything to the to the blank character. Have basically nothing in there initially. And in fact, you could say we should draw the board. We should draw either the static board or the dynamic board. And I think for the sake of demonstration, we'll draw the static and the dynamic back and back, which means our draw routine needs to be able to handle both the static and the dynamic board. In other words, we need to be able to pass in as a parameter, do we want to print out this or do we want to print out this? Alright, so what we'll do is, we said we want to make this a parameter, so we'll have a character, or we'll call it array. This will be a 3 by 3. Right, that's what's going to be passed in. So instead of hard coding it to always be the board static, we will instead now call this the array. So this allows us to pass in an array, and we'll print out the array, a 3 by 3 array. So that means draw board, we can now draw the board, the static board, and then we can draw the dynamic board. That way we'll see what numbers we need to put and also where we're at. So draw dynamic. And if I run this part, choose 2, notice we've got the numbers we'll need to enter and also the current box, what's currently in the boxes. So we see right now we have just blank spaces in the boxes. Okay. So with that, when we start a game, either the computers will go first or you're going to go first, right? So you could argue that when we say make next move, we need to first decide who's going to move first. And right here, this make next move. When we first come in here, we could say we want to decide whose move it is. And what I'll do is it's either going to be the computer's move or your move. And this would actually be a good case where we could have enumerated types. So I'm going to have a type def enum for enumerate, and I'm going to call it either computer move or your move. And this is going to be, we'll call it the move underscore t for the move type. An enumerated type, you list your choices. It's either going to be the computer move or it's going to be your move. Right, that's what it's going to be. So when we first come in here, we could say determine who moves first. Right, determine who moves first. And we'll say the move type of, we'll say the current, we'll say the first move is going to be equal to, we basically want to either choose this one or this one, right, one or the other. And what I'm going to do is we could generate a random number, or oftentimes when you just have two things, you could use the lowest most bit in the time thing that ticks, and this will either be a 0 or a 1, right? When you look at it from a binary perspective, numbers always either end in a 0 or a 1. So determine who moves first. I'll say let's do a time type of now equals, let's get the current time, Now we know we're missing a header file, so let's come up here, add our time header file. So include time.h. So here we're going to get the time, and then I'll say if, and this I'm going to take the value of now. In fact, just to show you how it looks, let's print out. Let's say now, and it's a, I believe it's a long unsigned. Let's see if that's right. Yeah, long unsigned. So that'll show us what it is. And we're going to take that value and we're going to do something we've not done before. Do what's called a bitwise AND. So bitwise with a 0, 1. So we take the value. The bitwise AND says look at every bit that's in that number. And bit 1, which is the lowest most bit, if it's set, then this would be true. And we'll say if set, computers move. And we'll say if set, if lowest bit set, then computers move. So we'll say, and you know this first move, I need to put it up here. So I'm going to move this from here. And I'll put this here. So the move type, the first move, so here the first move is going to equal to the computer move. Else, if it was not, if it was a 0, then our else condition will say first move equals the your move. So one or the other. And what that means when we say this make next move, we'll pass in the first move. That thing about, maybe we'll just call it the I'll say whose move. Whose move. So whose move. Whose move. And we'll pass into this make next move, pass in whose move it is. And thinking about it, this playing, instead of playing, we'll say whose move it is. And we'll say, wow, whose move does not equal to none. And then you say, well, wait a minute. There is no none. Well, we're going to add that. We're going to say, you know what? This enumerated type is going to either be none, or the computer move, or your move. These are the only 3 values it can be. So that will be anything that's a move type. It's either none, computer, or your move. And so based on this, when we come back, make next move, we pass in whose move it currently is. It returns us whose next move. And as long as it does not equal to none, we will continue running this. So let's go to the make next move. And for right now, we'll just return none. So what gets passed into this is the move type. I'll say the move. And for right now, we'll just return none. Because this, instead of returning a static, it's now going to return a move type. So basically, we'll immediately end for this part, but it's giving you insight into why you'd use an enumerated type. This is actually a good example of that. We wanted to have a data type that only had the values of none, of computer move, or your move. Let's run it and see what we got. Okay, tic-tac-toe. Cool. It shows the current time, And notice this 4, if we look at that, hex 4 in binary is 0, 1, 0, 0. So 0, 1, 0, 0. So I guess we should have said whose move it was. Let's do this. We'll say printf whose move, and we'll print out the move, and that will be as a decimal value. That'll help us learn this a little better, so I'll click on run. Okay, let's do 2. Now notice it said whose move was 1. In fact, why don't we do this even a little better? Let's switch on move. Let's switch on move, right? Move's coming in. And notice when I look at this, it says enumerated values none, computer none, and are not handled in the switch statement. So it knows we're not handling them. Well, let's say none. We'll say put string none, and then we'll break out of this case statement. The other case statement is computer move. Put string, it will be computer move, and then break out of that statement. And last, if we had your move, then we'll put string your move and break out of that. Now, we should never get to the default, and if we do, I'll say put string never. Right, we should never get there. So we should never even see this case. All right, let's give it a try. Okay, let's play Tic Tac Toe. It said the move was 2. So whose move? Oh, wait a minute, we should have printed out whose move. So come in here, I switch on the move. That's funny, I didn't see the move came in here. I do see this, whose move, it printed out a 2. Oh, we got the never. There we go. I got the never. Okay, we got a logic bug, right? We got never. In fact, you know what I should have done? Again, this is what I like about doing these videos. You see how the developer is thinking. Says this would be a good case. I probably should have called exit if this happens. I should just exit because I was never expecting to get here. And if I get here, something's wrong. So what I'll do, this exit, notice it's we're missing a header file. Well, we know, probably exit. Maybe it's in standard lib.h. Yeah, that's a pretty popular one. Let's see if exit was in there. Aha, it was. So I'll click, I'll run this again. Do tic-tac-toe. Never. So I've definitely got a logic bug, right? And this time we got exit status 1. So it raised the issue right away. Now when I came in here, I thought move could only be these values here. None, computer move, and your move. Why? Because that's what we said they were here. All right, we said those are my choices. But clearly when I come in here, I'm doing a bitwise and I should set it to either this, else I should set it to this. So it's definitely getting set. And then we pass it in as whose move. Gosh, that's kind of odd. It looks like to me it should definitely be either this or either this. And then, but instead we're getting never. So we come in here. Right, it has to be either set to this, and the else statement is going to get us to this. So come here, make new move, make next move. I do the switch. Now, as you know, I put in certain example errors because they're very common. I've seen them over the years. And the thing that should be catching your attention, we're not getting any compile error. Right? I mean, everything looks fine. But yet, we're getting never. Well, watch this. This should be a major learning. We were missing case. We were missing case. And although we haven't looked at it, it turns out the computer was, the compiler treats this as a label, something called a label that you use when you do go-to statements. So it was actually okay to do this. But within a switch statement, always have your case. So hopefully by watching this, and maybe you even caught the error early on. If so, that's really good. But this is one I've seen students really get stumped on, and it's simply because they've forgotten the case. So now when we run it, right now it says, oh, it was the computer's move. Let me run it again. Computer's move again. Let's do it again. Your move. All right, so we got us that part, and I'd say this is probably a good place to stop the video. Make sure you've got your code where you at least know who's going to make the next move, and we'll pick it up in the next video. I'm Norman McIntyre. Thanks as always for watching.